Dear students, let us continuing learning the course Data Structures and Applications. Today we are in the first session of the module 2. The topics covered under this session will be stacks definition, stack operations, array representation of stacks, stacks using dynamic arrays. I am Dr. Suresh from the Department of Computer Science and Engineering from Canara Engineering College, Bantwal, Mangaluru. The course outcome mapped to this module. At the end of this module, the students are able to develop the programs on operations like searching, insertion, deletion, traversing mechanism on stacks and queues. First, let us start with the definition of the stack. A stack is an ordered list in which insertions and deletions are made at one end called the top end. Let us look at the example which are presented at the down over here. A deck of cards or a pile of plates. In these two arrangement, whenever I want to keep a new plate, where will I keep? On the top of the previous plate I will keep. If I want to delete or remove a plate from this pile, from where will I remove? From the top I will remove. Such an arrangement wherein the insertion and deletion both will be carried out at a single end. Can I remove the plate from the in the middle? No. Can I remove the plate from the bottom? No. From where can I remove? Only from the top end. Such an arrangement of elements wherein the insertion as well as deletion will be carried out at one end, we call such an arrangement as a stack. That is, the inserting or deletion will be performed at a single end. The inserting an element to the stack, we call it as a push operation, and deleting the element from the stack, we call it as a pop operation. These are the two primary operations which are performed on the stack. That is, insertion, we call it as a push operation. Deletion, we call it as a pop operation on the stack. If we go for representing the stack, let the stack be S, which will have some n elements, say A0, A1, A2, A3, going on up to An minus 1, wherein A0 is my bottommost element, An minus 1 is the top element. How the elements are placed? Bottommost, A0 will be placed, on the top of it A1 will be placed, on the top of it A2 will be placed. The series continues till An minus 1. If we go for generalizing this one, A1 will be on top of A0, A2 will be on top of A1. In general, Ai will be on top of Ai minus 1. Such an arrangement will be your stack. Now if you go for the abbreviation of the stack, the stack is also termed as last in first out, LIFO list. That is, the last element which will be inserted to the stack is the first one which is to be deleted from the stack, or the first one which will be inserted to the stack will be the last one which will be deleted from the stack. But in general, we call the stack as last in first out, that is LIFO list. If you go for a simple example, initially no elements are there, I will push the first element to the stack. Let the first element be A. Inserting to the stack, we call it as a push operation. Next, I want to push B. How to push B? Increment the top pointer value and push B. Next, I want to push C. Again, increment the top value and push C. Now, what are all there in the stack? Top, we have the C. Next to it, we have the B. Next to it, we have the A. Next, I will perform the again push D over there. Now, what is there on the top? Top will be D. Beneath that one, we have the C. Beneath that one, we have the B. Beneath that one, we have the A. One more push operation I will perform. Where is my top value? Top will be there pointing to E. Beneath that one, we have the D. Beneath that one, we have the C. Beneath that one, we have the B. Beneath that one, we have the A. Now, which is the last element which was inserted? E. Which is the first element which was inserted? A. Now, I want to perform the pop operation. What is pop operation? Deleting the element from the stack, we call it as a pop operation. Now, which is to be popped out? Whether E or A? That is E. Why E? It is the last element which was inserted. That is, the last element which was inserted is the first one. It is to be deleted from the stack. Such an arrangement we call it as a stack. That is, the first element inserted was A, and it is the one which is to be deleted last. That is, last to be inserted is the first to be deleted, or first to be inserted will be the last to be deleted. Now, let us go for learning the representation of the stack. There are many ways with which the stacks can be represented. Commonly used ways are, first one will be the linked list or the arrays. When we go for the arrays, again two options are possible. We can go for the linear arrays, or we can go for the dynamic arrays. When we go for the stack representations, we normally come across two variables. One will be the top variable, other one is the maximum stack size variables. Stack always have these two variables for its representations. The top will point to the location of the topmost element in the stack. If no elements are there, then the top will be equal to -1. That is not 0. 0 is an index value. Top, when no elements are there, then the top should be equal to out of that first index value. What is the first index value? 0. Out of it, what is out of that value? That is a -1. So, incrementing that one should go to our first index value. That's why the top will be initialized with a -1. That is to check the stack empty case. This is the condition we check. What is the condition we check? The top value will be equal to -1 when the stack is empty. And the max stack size will give us the number of elements that can be stored in the stack. In this example, if you look, the max stack size is 8. Means we can store 8 elements. So, starting from the index 0 to 7, we can store the 8 elements over there. When I reach my top value to 7, it symbolizes that the stack is full. Till I reach 7, I can go for inserting the elements. That is, for the full case, the top should be equal to your max stack size -1. For the empty case, the top will be equal to -1. Now, let us learn the various operations which are performed on the stack. First, let us go for creating the stack. Whenever we go for creating the stack, each element is of highest importance. Let us take an example of your student as an element. So, what are all the components which are present in the student element? The name of the student, your USN number, your address, your marks. To hold these 4 fields, we need the different types of data types. First, let us start with your name. Name should be a string. then the USN, again it's a string with a size of 10, again your address, then next one will be your marks. How the marks will be? Marks should be of type integer type. That is, we have the fields wherein 3 are of type string and 1 is of type integer. Now how to combine these four types? The one such prototype will be the structure. The structures can be used for creating the element. That is the same thing we are doing over here. That is, we are using the structure prototype for creating the element over there. For the representation purpose, have used only one element for each element. That element will be my key. Now here I am defining my maximum size will be 100. That is, what is the index values? Will be from 0 to 99. Now I create the stack over here. How I am creating? It is an array. What is the type? Element. Stack will have a maximum stack size, that is 100, with the top initialized to -1. Why top initialized to -1? Because no elements are there in the stack. So I am initializing top to -1. The first obvious question will be, why top not to 0? 0 is an index value in the array. You should remember that one. You have learned this one in your previous semester. What you have learned? The array representations will start with an index value of 0. That is, 0 is a location. What the top will point to? The top will point to always the element which is there on the top. Now since no elements are there, if I put it as 0, it should point to that 0th index. But no element is there. Then what should be the top value? It should be always the -1. So the top will be kept to -1 over there. Then the next operation will be to check the stack is empty. What is the return type over here? Boolean. Boolean means either the true or the false. If the top value equal to less than 0, then it will return a true value. Less than 0 means what? What is the value less than 0? -1. Whenever the top value is -1, it will return the true value. Means the stack is empty. Or else it will return the false value. But that false value, stack is not empty. Next is full. Again it is a boolean value. What the boolean values will have? Either the true or the false. Whenever the top value will be greater than or equal to max stack size -1. In our previous example we have seen. What we have seen? There are 8 elements we can store over there. Then what was our last index value? It was 7. When it was 8 elements can be stored, the last index value is 7. In the same way, if I can store 100 elements, then what will be my last index value? It will be 99. In the same way, when the top is greater than or equal to max stack size -1, means the stack is full, or else it is not. Whenever the top satisfies this condition, it will return a true value, or else it will return a false value over there. Next important operation, push operation. What is a push operation? Push is inserting the element to the stack. We call it as a push. Before doing the push operation, what we need to check? Whether the stack is full. How to check that condition? If top greater than or equal to max stack size -1, then the stack is full. If stack is full, what to do? You have to exit, because we can't insert the element. If the stack is not full, then the control will come to the next line. What we are doing over here? We increment the top first. That is pre-increment we are doing. We increment the top first. Then I copy my element to the stack. That will be my push operation. Next, pop operation. What is pop operation? Deleting the element from the stack. We call it as the pop operation. Then what is the condition I need to check over here? Whether the stack is empty. Can I delete an element from the empty stack? No, it's not possible. That condition we are checking. If top equal to -1, means no elements are there in the stack, then we return stack empty. Or else we return the top element and we decrement top by 1. Here we are doing the post decrement. Means first we return the top element which is to be deleted. Then the top is decremented by 1. That will be your pop operation. Then what to do when the stack is full? Print the message stack is full. We can't add. Then we exit from the routine. So these are the operations what we perform on the stacks. Fine. Now the major limitation in the representation of the stacks using linear arrays will be the size of the stack. It is restricted. The size should be known in advance. During the compilation time, we should know the size. Only then we can go for the linear arrays. But in most of the cases, what happens is we don't know the size in advance. In those circumstances, putting a bound is not possible. Now, what is the solution for that case? We need to go for the dynamic arrays, wherein I can go for increasing the size of the stack whenever the stack is full. For that reason, we go for representing the stacks using the dynamic arrays. Now, when I go for representing the dynamic stack operation using the dynamic arrays, what happens in the rest will be the same. The first difference will be over here. What we are creating over here, it is not in a linear array. Here we are creating the pointer array over here. In place of restricting the size, we are creating the pointer array. Then we go for dynamic memory allocation using the malloc function. Initially, we kept the capacity will be equal to 1. Once the capacity is satisfied, we go for doubling its size. So no elements are there in the stack. We keep the top equal to -1. Same is empty case. When the top is less than 0, it will return the true, or else it will return the false. Next is full case. Whenever the top is greater than or equal to the capacity -1, we return a true value, or else we will return the false value over there. In the push operation, whenever the top greater than or equal to capacity -1, we go with the stack full function, wherein we go for doubling its capacity. Once the capacity is doubled, then we go for copying the element. We will copy the element to the top of the stack. That is, we increment the top value, then we copy the element over there. Pop operation, it remains same. What it is, if top equal to -1, no elements are there in the stack, we return empty, or else return the top element and decrement top by 1. That will be your pop operation. Then stack full, we have already seen. What we have seen, whenever the stack is full, we are going to increase the capacity by a factor of doubling it. Every time we go for doubling its capacity. Next, if we go for analyzing the array doubling capacity. So what happens here? Every time when the stack is full, we go for doubling its capacity. That is, capacity is multiplied with a factor of 2. But what happens over here? Every time whenever I will double my capacity, I need to copy my old contents back to my stack. That is, each copying will take a big O of 1 time. If I already have n elements in my stack, now what will be my complexity? Big O of n. That is, the complexity will be big O of n if I go for doubling the stack. It will be big O of n. So that many push operations we need to perform. These are the textbooks from where we prepared the presentations. These are your prescribed textbooks for the studies. So to summarize, let us go for summarizing what all we have learned in this session. First, we went with the definition of the stack. What the stack is? Stack is an arrangement of elements wherein the insertion and deletion will be performed at only one end. That end we call it as a top end over there. and it is called as a last in first out data structure. Each insertion to the stack we call it as a push operation. Each deletion from the stack we call it as a pop operation. Stacks are represented in many ways. The most commonly used ways are linked list, linear arrays, and dynamic arrays. In the linear arrays, the problem is once the stack is full, we can't go for increasing its size. That is the limitation. That is, the size is to be known in advance. That limitation is relaxed in case of dynamic arrays, wherein we can go for increasing the size by doubling its capacity once the stack is full. Thank you. We'll continue the session in the next. We'll continue our session with the next topic.